Alright, so in 4.4 we're going to talk about kind of applications. There are 4 different applications we're going to tackle. For one day we're going to tackle mixtures and principal and interest. I'm going to give you a couple of different examples. You can go through a couple different examples in each of mixtures and each of principal and interest and kind of use the idea of applications of systems of equations, because we're in systems of equations and we're just going to go through some applications. So let's go through the first application, mixtures. We're going to talk about mixtures first. So here's a mixture problem. I'll read it to you, I guess, just to make sure that we got it. According to new hospital standards, a certain disinfectant solution needs to be 20% alcohol instead of 10% alcohol. So we've already got 10% alcohol solution. We need to make it 20%. There is a 40% alcohol disinfectant available to adjust the mixture, so we can add some of that 40% to the 10% that we already have to get that 20% that we need. So we need to determine the amount of 10% solution and the amount of 40% solution to produce 30 liters of a 20% solution. Sounds like a lot of stuff out there, but we really have to think about a couple different things. I guess this is the way I would think about it first. I would say, let's see, what do we have? What are we going to add to it to get what? So we already have a 10% alcohol solution, right? So let's put over here a column for 10% solution. And let's see, it needs to be 20% solution, right? So we're going to put 20% solution over here, and we're going to add 40% solution, some 40% solution to adjust the mixture. So there is a 40% alcohol solution to adjust the mixture, so we're going to add some of that 40% solution to get to our 20%. So we're starting with 10%, we're adding 40%, and we're actually, I'll rephrase that. We start with some amount of 10% solution. We're going to add some amount of 40% solution to get some amount of 20% solution. And some of that stuff we know, or we are given from the information in our problem. So I'm going to set up a table. We're going to have, because we've been dealing with systems of equations, I'm going to set up one row here and one row here, because that will, this line will become a system of equation, will become a line or an equation. This line here will also become a line or an equation. So let's see what else we've got. Now we've got, so we kind of use that information, we use that information, we use that information, we use the 40% already, we used the 20% already, so that information is kind of present here. And now we really have to define, or kind of find out, what we're looking for. What's going to be our end goal? So we need to determine, again, if there's a question or a statement that says determine, or determine the amount of 10% solution, for example, the verb says determine. So we need to find out what? The amount of solution and the amount of solution. So I'm going to say, let's define some things that we're going to look for. Define, let's see, x is, because we're going to deal with x's and y's, we're familiar with dealing with x's and y's. Define x as the amount of 10% solution. So amount of 10% solution, 10% solution. Then also define y as the amount of, let's see, amount of 40% solution, 40% solution. All right, so then we've already got, we kind of know what we're looking for. We're looking for x, the amount of 10% solution. We're looking for y, the amount of 40% solution. So now we have to just kind of figure out what goes up here and what goes over here. Well, they're giving us some information. Let's see, what colors haven't I used? Green. They give us 30 liters of solution. So you know what? I'm going to put up here liters, because that will define some kind of information that we know. And the amount, I guess, of 10% solution is in liters, I suppose, because we need to know how many liters there are. And we need to know how many liters there are of the 40% solution. So here, right here, x is the amount of 10% solution, the liters of 10% solution. So x would go right here, by the same token, y would go right here. Y, the amount of 40% solution in liters, goes right here. 40% liters goes right there. I'll clarify this. Liters. L-I-T-E-R-S. Up here it says we need to produce 30 liters of a 20% solution. So we need 30 liters right here. 30 liters right here. We wouldn't put an L there because it's already, in this table it's just numbers, because we know that the column describes liters. So there's some information that we put in there. Now the other one that we really haven't talked about, and really is kind of talked about up here but not specifically, and not told specifically you need to work with that, is the amount of chemical that we have. So the amount of chemical is alcohol. I'm going to put in general chemicals here because we'll use the idea of chemicals not only here but in all mixture solutions. So how much chemical is in, let's go over here. I'm going to talk about this one because this one talks about specific numbers. So I'm going to ask about how much chemical, in other words, how much alcohol is in my 20% solution if I've got 30 liters of it. Well, 20% of 30 liters, if I go down here and I say, well, 20% of 30 liters is 0.2 times 0.2 times 30. This is equal to 21 hundredths is 0.2 multiplied by 30 liters. So it's 20% solution of alcohol. So 20% of it is alcohol. 0.2 times 30 is alcohol. What's 0.2 times 30? Move the decimal point once, move the decimal point once, you get 6. You can take out a calculator as well and do that calculation. That's not a problem. 0.2 times 30 is 6. And that's how much chemical is right up here. So I'm going to write down, let's see, in real small letters, 0.2 times 30, just to get the idea that that goes right here, 0.2. And that's how we got here. 0.2, because 20% is 0.2 in terms of numbers. 0.2 times 30 gives us 6. So by the same token, what goes over here? We would say it'd be 10% of X liters. Well, by the same idea, it's, well, let's see, 10% times X liters is 0.1 times X liters equals 0.1x. And that's what goes up here, 0.1x. So what goes up here? Should be 40% of, or 0.4, 0.4 times y. 40% of this solution is alcohol. So 40%, 0.4 of y liters is alcohol. And that's what we're talking about right here in this black row, is the amount of chemical. In this case, it's alcohol. So now that we've got our two rows set up, I have a green row and I have a black row. Green row talks about liters, black row talks about chemicals. We have now set up pretty much a system of equations. From this green row, I can say that x plus y equals 30, because the amount of liters of 10% plus the amount of liters of 40% has to equal 30. So x plus y equals 30. By the same token, we can say that the amount of chemical in this 10% solution, or this first solution, plus the amount of chemical in this 40% solution has to be equal to the amount of chemical in this final solution. So you add these up. 0.1x plus 0.4y equals 6. And right there, the green and the black make up a system of equations. And now we can look at this system of equations, x plus y equals 30 and 0.1x plus 0.4y equals 6, and say, you know what, how do we solve that? Let's see, we have 3 different ways. One is graphing. I wouldn't recommend graphing. I would not recommend graphing. So we've got graphing, but we throw that one away. And that leaves substitution or elimination or addition method. The elimination addition method is kind of the same method, but it is the same method, but just different wording for it. I would not recommend substitution. Substitution, you could kind of, put this green in terms of x or y and then substitute over here, but you're kind of dealing with decimals then. It just doesn't lend itself real well. So what I would recommend is I'm going to change into red, and I'm going to say, let's see, what I would do down here would be I would change this black equation and multiply by, let's say 10. If we multiply by 10, the coefficient here, 10 times 0.1 is 1. And that gets us, that eliminates all these decimals and it kind of gives us whole numbers. But you know what? Let's kill two birds with one stone and multiply by negative 10. If we multiply by negative 10, then the coefficient for this x becomes negative 1. And then when we use the addition method, we could cancel out the positive 1 up here. Positive 1x minus 1x. So let's rewrite over here and say I'm going to multiply my black by negative 10. And that will give me 0.1 times negative 10 is negative 1x. And I'll put the 1x there just to make sure that we know that it's 1. Positive 0.4y times negative 10 gives us negative 0.4 times 10 is multiplied by 10. You move the decimal point to the right. 4y equals, and don't forget the last number here, the coefficient, or sorry, the constant number here. We got to also multiply that by negative 10. 6 times negative 10, negative 60. All right. So now the green equation pretty much just stays the same way. X plus y equals 30. And now we're pretty much done. We can just simply add up what we've got. I'm going to change colors here to blue. So we can add up the green and the modified red and modified black, which becomes red. X plus negative x goes away. It's 0. Plus y minus 4y is minus 3y equals 30 plus a negative 60 is negative 30. Divide by negative 3, divide by negative 3, and we get y equals negative divided by negative is positive, 30 divided by 3 is 10, and there's part of our answer. And again, we're looking for a solution to a system of equations. So if we're looking for a solution to a system of equations, we have to have an x and a y, because we define those two variables, and that's what we're asked to find, determine the amount of 10% and the amount of 40% solution. So we found y, the amount of 40% solution is 10, and we can just go back up in here to the green equation. We can take this, y equals 10, and put it back up into the black equation if we want, but it's easier to go into the green equation and say that, well, x plus y equals 30. Well, shoot. All right, we'll go the long way and say, well, x plus y equals 30, y equals 10, x plus 10 equals 30. Subtract 10, we get x equals 20. You could also justify just looking at it and saying, well, they both have to add up to 30, and this is 10, it's got to be 20. So now there's your answer. X equals 20, y equals 10. We can double check by putting x and y values up here. 20 plus 10 is 30. Sure enough, it checks out. And now let's double check our 0.1. We'll switch to black. We'll double check here. 0.1 x plus 0.4 y equals 6. 0.1 times x, 20, plus 0.4 y, 10, equals question mark, negative 6. 0.1 times 20 is, if you multiply by 0.1, you're actually dividing by 10, so this would be 2. And you can take out a calculator if you need as well. 0.4 times 10 would be 4, equals question mark, whoops, that should be positive 6. I don't know why I put a negative 6 there. 2 plus 4 equals 10, 2 plus 4 equals 6. Yep, sure enough, it checks out, and we're done. And we've set up our system of equations by simply looking at, by looking at two different things. Number one, the liters of stuff that we're looking at, because they gave us liters here. We have to set up one row as liters. We have to set up another row as chemicals, the amount of chemical that we have, and that's the trick to setting up the mixture problems. Liters, or amount of stuff that you've got, and chemicals. How much chemical do you have? This could be alcohol, this could be antifreeze, this could be any kind of chemicals that we've got, salt. And the trick then also is figuring out how much you have, what you add to it, and then what you get. And you got to pay attention to that up here in the wording. But there is a system of equations, or an example of using a system of equations to solve mixture problems.